So here are a few examples where you are given information about zeros, intercepts, asymptotes, and then you have to find a possible formula. So this is going to work backwards from here's the formula, what are all of those items, what are the zeros, what are the asymptotes, what are the intercepts, and this is going to actually find the formula for it. But we're going to use some of the information that we know. So like to start with, zeros given. Well, if you recall, zeros are what make the numerator of your rational function equal to 0. So if we have a rational function, here's our rational function, the fact that zeros are at -3 and +2, I'm going to change into factors of x plus 3 and x minus 2. That's reflecting the fact that I have zeros of this rational function, and zeros from a rational function can be found by setting the numerator equal to 0. The other thing that I know is that there are vertical asymptotes at -5 and +7. Well, vertical asymptotes are what make the denominator equal to 0. So I'll take those two values, -5 and 7, put them into factored form on the bottom. So I get x plus 5 and x minus 7, and there's my denominator for this to satisfy the vertical asymptote. There's no y-intercept given here, but you do need to note that it is supposed to have a horizontal asymptote of y equals 1. So if you recall from previous discussions, the horizontal asymptote is a number if the coefficient, if the degree of the numerator is equal to the degree of the denominator, and you pull off that coefficient, and that coefficient is what your asymptote is. So the fact that we have an asymptote at 1 means the degree of the top equals the degree of the bottom. And when I pull those numbers, their coefficients, the ratio of their coefficients is 1. So currently, I have an x squared on top and an x squared on the bottom, and we do satisfy that. So that should be the only thing that we have to do for this kind of problem, in that you don't really have any other information. You don't have, had that horizontal asymptote been something other than 1, like for example, had the horizontal asymptote been y equals 4, we would have placed a 4 out front. Or had the horizontal asymptote been y equals -3, we could have put a -3 out front, so that when you expand, you'd have -3x squared over x squared, or 4x squared over x squared. But we don't need that here, and we can answer with the function x plus 3 times x minus 2 over x plus 5 times x minus 7. Right? Here's another written out one. So we've got one vertical asymptote at x equals 1. So if I go to create my function, remember vertical asymptotes are values that make the denominator undefined. So an asymptote at x equals -1 is going to make me put an x plus 1 in the denominator. The horizontal asymptote piece at 1, again, is just going to mean that my numerator degree is equal to my denominator degree, and when I pull off their coefficients, they're going to equal 1. So we'll come back to that concept. The graph crossing the x-axis, or the y-axis, at y equals 3 is a y-intercept at 3. And the x-axis crossing is your x-intercept, and it only crosses once. So x-axis, that's your x-intercept. Remember, on a rational function, that's what makes the numerator 0. So if I have a -3 x-intercept, then I'll have an x plus 3 in the numerator, so that I get my x-intercept at -3. The only other thing that we need to make sure it satisfies is that it has this y-intercept at 3. Remember, y-intercept at 3 is where x is 0. And we also need to make sure that our coefficients, like the x over x, pull a coefficient of 1. So if you recall from before, when we did a polynomial, there was a constant out front, top polynomial, bottom polynomial. So if you'd like to just verify, finding a constant times your polynomial, you can use this y-intercept of 3, plug in 3 in for y, 0 in for x's, and you'll get that k is in fact 1, and we don't really have to put anything else on our function. So x plus 3 over x plus 1 would satisfy all of these pieces. It satisfies a vertical asymptote at -1. It satisfies a 0 at -3. It satisfies the asymptote y equals 1. The degrees are the same. 1 over 1 gives us our horizontal asymptote. So we satisfy all of those things that we need to for this function. So x plus 3 over x plus 1. All right. You may be given a graphical representation where you have to find a formula. So we'll give formula that's possible for this rational function. But we're going to pull all the information as we were given from the previous two examples. So looking at this, I can see I have a vertical asymptote at x equals 2. So that's going to drive my denominator. So here's my function. So x minus 2. I can see that there's a horizontal asymptote at y equals -1. So what that means is the degree of the numerator is going to be the same as the degree of the denominator. And when I pull coefficients off, that coefficient needs to have a ratio of -1. So there's got to be a negative somewhere. The other thing that we're given is there's a y-intercept at +1/2, and there's an x-intercept at -1. So the x-intercept at -1 is that's your 0. So that means we're going to have an x plus 1 in the denominator. So we have that picture going on. And the only other thing that we need to make sure that we satisfy is that y-intercept be +1/2, and we have that horizontal asymptote at -1. So the only thing that we're really missing to try to make sure we have the right thing is this constant. So if I use my y-intercept of half, 1/2 equals k times 0 plus 1 over 0 minus 2, you'll see that the constant is going to have to be -1. Because if my y-intercept is +1/2, if I solve for k in this equation, dividing both sides by -1/2, I get k is -1. You're going to have a negative on your rational function, whether you put it out front or whether you put it in the numerator. It's going to have a negative on that function in order for the y-intercept to be correct. And also, this y equals -1 for a horizontal asymptote. If you pull leading terms of -x over x, -1 over 1, you'll get your horizontal asymptote and -1 like we need to have for this function. So final answer here is negative of the function x plus 1 over x minus 2. Okay, here's one more. It's a little bit more detailed, but again, you're still pulling the information from this function. So vertical asymptotes are at -1 and +2. So that's where the denominator is going to be 0. So if we come to our denominator, I'll put x plus 1 and x minus 2. Zeros for the function, where it crosses, where it has to do x-intercepts. Those happen at -2 and 3. So those are going to be zeros in the numerator. So if 0 of -2, a factor would be x plus 2. 0 of +3 would be a factor of x minus 3. The other things that you can note from here, there's a horizontal asymptote at y equals -1. So again, the fact that there's a horizontal asymptote means the degree of the numerator equals the degree of the denominator. And when I pull their coefficients need to have a ratio of -1. Currently, I just have x squared on top, x squared on the bottom. So I'm going to have a negative in there somewhere. You're also given the fact that the y-intercept is -3. So I should be able to use the point 0, -3 to verify what k might be for a constant out front. So again, you'll just make your y equals, with all the other information that we have, plug a -3 in for y, plug 0 in for all of the x's. So go through and find what k should be. So the top is -6, the bottom is -2. That would be +3. So here we have another example where k is -1. So our final formula, possible rational function equation, is going to have a negative out front on the x plus 2, x minus 3, and x plus 1, x minus 2 quantities. But you have to make sure that that negative is there to go with the fact your horizontal asymptote was at -1, so your coefficient ratio is -1. So we have that now. And that allowed us to have the correct y-intercept at -3. So that is a possible formula that creates the given graph. But you just use your intercept information given, use your asymptotes. Remember, vertical asymptotes go in the denominator, x-intercepts create the numerator, and any asymptotes that are given will be a direct result of how those leading terms in the numerator and the denominator affect each other. Sometimes the constant will be 1. Sometimes you'll have to make it another constant, like 2 or 4 or 7, and sometimes it'll be negative. So use your intercept value for y. Use every other property that you have from the graph. And of course, you can always graph your final formula to see that it matches the graph that you were given for the problem, or the information that you were given, rather.